Good afternoon, everyone. My name is Vikram Balasubramanian. I'm a senior solutions architect for AWS supply chain. So, ever since pandemic, there's been an elevated interest in getting accurate demand plans with our customers. So, as part of our walkthrough today, I'd be walking through AWS supply chain's demand planning capability. So, let's dive into it. So, first step that we are going to look at is how the demand planner can easily set up their demand plan. So, the first thing that we are looking at is to define the demand planning problem. So, it involves defining what the planning horizon needs to be. So, in my example, I'm going to choose a monthly planning forecast, and I'm going to select 12 months out to be the planning period. Now, the next step that we are going to look at is how you define the planning granularity. Now, if you were to take a step back and look at it from a demand planner perspective, this includes defining the dimensions of how you want to create your demand plan. At the root level, the first thing that we need to be looking at is product hierarchy. So, obviously, from a supply chain standpoint, you are looking to plan products or SKUs. Now, typically, across all industries, you will have a categorization of how you define the product hierarchy. So, you have multiple levels that defines the product hierarchy effectively. So, within AWS supply chain's demand planning capability, you have the option to model up to 10 levels. So, here for our demonstration purposes, I'm going to stick with just 2 levels, product group ID and product ID. Now, the AWS supply chain's demand planning capability just doesn't stop there. It also exposes certain alternate hierarchies for the demand planner to take advantage of. Now, you might wonder what that actually means, right? So, let's say from a planning standpoint, you want to plan by a particular location. So, under site hierarchy, you can choose ship from site ID as an example. Similarly, if let's say you are looking at outbound order fulfillment, you would want to define what is the channel that you are trying to sell through, right? Is it through e-commerce or is it through brick and mortar and so on. So, the channel hierarchy attribute, that particular drop-down allows you to define your planning from an alternate dimension. And finally, if you want to also add in the nuance with respect to a customer dimension, you could bring that information into our demand planning tool as well. Now, at this point, the assumption is that the application has the data that it needs to generate the demand plan. But we all know that not all data is equal. There are data quality challenges and data integrity challenges that comes with your data set. So, not to worry, the application allows for users to control how those input data points are massaged before getting into the planning engine. So, here we see an example of if your data set has negative values, how does the application treat that? So, you could either ask the application to ignore the value or to replace it with 0, which is what we will choose for our demonstration today. Now, the key thing to keep in mind is that these inputs are set once by the planner in line with your business process, and it helps preset the planning from our application standpoint. Now, you might wonder, not all products are treated equally, right? So, you might have certain products which from the beginning of time keeps recurring in your operations, in your day-to-day operations, and then you have certain products which are new products, right, that you are looking to launch maybe a week from now, a month from now, and so on. So, the cool thing about AWS supply chain's demand planning capability is that the application gives the control to demand planner to say how the start and the end timeline for these products needs to behave. So, imagine if you are launching a critical product for like promoting a certain product that is key to your business. So, AWS supply chain lets you preset or define the time period for which you want to launch the product. So, you are in time to support the launch for the product. Now, before I move away from the screen, another point that I wanted to raise is with respect to initialization of the forecast. Now, typically when we look at products that don't truly fit the new product definition, nor does it fit a product lineage or association with another product, for those products, the challenge really is to get an initial forecast value into play. Now, for that, we have the new product initial forecast option, which presets the forecast on behalf of the demand planner. Now, the core idea here is to simplify the operations from a demand planner perspective. So, the application does the heavy lifting on behalf of our customer. Now, finally, before we move away, we would want to let the application define how the plans are going to be published. So, there are two modes available. One is the automated mode and the other one is the manual mode. So, keep in mind, automated mode allows for demand planner to set a specific cadence for publishing the demand plan. So, let's say you want to generate a plan, a weekly plan, and want to publish it every Sunday night, you could put that on a timer here. Now, with all these inputs, the application is now ready to compute the demand forecast. So, a final word of confirmation before we get to the final step is the location where the plan will be available once the demand planner is ready to execute on the plan. Now, here another key interesting point to note is that the output of demand plan is available in an S3 bucket. Say, for example, you could consume that information to how you want to feed it to a downstream system or to share it with other users. Now, I'm going to go ahead and click on finish, and that's going to get me the result that we need to see from a demand planning perspective. So, in order to get to this point, we leveraged product data and we also leveraged the demand history data. Now, at a quick glance, the application tells you the number of products that you planned for, the number of sites, channels, and customers. Because if you remember, those were the nuanced dimensions that we modeled into the equation. Now, on the demand plan breakdown widget, the application gives a very nice breakdown of the different products that you carry within your organization. Why is this critical? Because the common question that comes up with demand planner is that, hey, I have 1,000 products, but I'm really struggling to get a mix of how those products are, right? Some of them are core products, some of them are new products, and some of them are like, just residual products. So this widget gives you a breakdown of those products. Now, the AWS supply chain's machine learning capabilities comes to fray when it comes to demand planning problem. Now, one artifact that demonstrates that notion is the overall influence factors. Over a period of time, companies are looking for innovative ways to understand what are some of the external factors that influence the demand. Classical example here is the number of black umbrellas sold in New York City, right? With the color attribute playing a key role on how the demand forecast is generated. Now, in line to that request from our customers, the machine learning model also teases out the top performing attributes or the top attributes that truly influence your demand, right? And we see a sample representation there. Now, obviously, we need to benchmark the forecast that is being generated against what the actual results are looking like. So, with that notion in mind, the application also generates forecast accuracy metrics to sort of self-evaluate with every time the forecast is being generated. Now, if we go to the detail page, and this is where the majority of time the demand planner is going to spend, right? So, if we look at the makeup of this page, we see that it populates at the highest level, meaning at the all products level. But notice how the application is also giving you a breakdown of certain key traits. So, in this example, I have 6 new products that are about to be launched, and there are 5 products which is reaching its end of life. Now, the reason why this is very critical from a planner perspective is that it lets them know where they need to be focusing their attention. So, as a demand planner, my priority would probably be to look at the new products first and then come to the end of life products. Now, if I look at the result in the bottom of the screen. So the application displays it both in a graphical format and in a tabular format. Notice how the application is also benchmarking the forecast against the prior time period's performance. So you see in the gray line, in the gray dotted line below, that's going to be the forecast for the prior year if you want to get a base of reference. Now let's look at a specific use case where imagine this scenario to be a B2B scenario, and you receive a call from your customer saying they are going to run a promotion and you need to support a 50% higher demand than what your forecast is actually saying. So we are going to pick a product. I'm going to choose brake pad for this example. And you notice how the forecast changed as I made the selection to a different level. Now, because the call is coming from a specific customer, I'm going to choose that customer, and you would see the forecast adjusting based on the selection that I made. Now, with AWS supply chain, we leverage the Amazon.com's learnings and knowledge when it comes to understanding how forecast is being generated. So the machine learning models are largely inherited from the learnings from our .com side of the business. Now, there might be situations where the demand planner have to engage with the demand plan to enter some external input. So here, the example that we are looking at is a product that is sold at a customer, ABC Auto Parts, and I just received word that they are going to run a promotion which is forcing me to increase my forecast by 50%. So I'm going to go ahead and click on bulk edit, and I'm going to choose the time period for which the change needs to be made. And as a demand planner, I have a couple of options. I could either increase the forecast, decrease the forecast, or set it to a fixed amount. So here, because our use case says increase, I'm going to choose increase. And you could control it by an absolute value, which is the amount field, or a percent, right, which is a relative adjustment. So I'm going to say percent. I'm going to type in 50 and add a note here, because they are running some campaign, they want to increase the promotion. I'm going to flag this as promotion. Now, one thing that you notice that as soon as I hit save and update, the application adjusted the forecast plan, but the key thing to note is that the application also registered the change from an audit trail perspective. Now that's a key thing to note, because from a demand planner perspective, the common challenge is that people tend to make changes, but they tend to forget to add a reference or the reason behind making that change, both for audit trail purpose and for future learning purpose as well. So here within the tool, not having to leave anywhere, the application inherently captures that change along with the plan. So you have that information with you. Now let's assume that this is the part where the forecast plan is all set and I'm ready to push it to downstream system for execution. So if you notice at the beginning, I set the publish schedule to be manual. So I'm going to go ahead and click on publish button. What this does is it's asking for a confirmation to say if all the changes that needs to be made on this plan is final and I'm ready to push it to downstream system, which in this case I am. So I'm going to go ahead and click on publish, push on the publish button, and that message popped really fast, but the confirmation was to say that, yeah, I acknowledge that this is the plan that you want to execute and it is available in your S3 bucket. So let me quickly summarize. So we looked at AWS supply chain being a purpose-built business application that runs machine learning algorithms to let you run a resilient supply chain. Specifically today, we looked at the demand planning capability, which generates accurate forecasts using machine learning algorithms. And we also saw a couple of things. We saw how the application has a flexible UI where the demand planner can not just review the forecast, but also interact with it in real time. And we also saw a use case where if there are external inputs that are coming into your demand plan, how does that impact your final plan that you want to push to downstream system, right? So I'm going to maybe pause here. We have roughly about 5 minutes. Would love to hear any questions or anything that I can explain in more detail from the audience here.